We started talking about the domain of a logarithmic function in our Zoom meeting. So what do? You set the argument greater than 0. So I think I will do B at A and B here, and I can also start another video to go over the little bit more challenging problems, which involve solving polynomial and rational inequality. Great review for section 2.6, but it's a little too much to me for me, honestly. But the A and B is going to be perfect. Alrighty. So what do? You find the argument, and argument is just whatever is inside this log expression. So what do I mean by argument is this: 8 minus 2x. That needs to be greater than 0. That is the condition. So you really set it up as 8 minus 2x is greater than 0. And remember, it is not greater than or equal to it. It has to be just greater than 0. And you solve this. First, subtract 8 from both sides. If I do that, I'll get negative 2x is greater than negative 8. Divide both sides by negative 2. Dividing by a negative number will make our inequality to flip to the other side. So x is smaller than negative 8 divided by negative 2 is positive 4. So if x is smaller than 4, x will keep on going to the left. So the left bound will be negative infinity, and the upper bound is 4, but it has to be smaller than 4. So I will close a parenthesis instead of a square bracket. So for domain of logarithmic functions, you will not draw square brackets because it is x is greater. The argument is greater than 0 instead of greater than or equal to 0. So let's go ahead and look at the second one. I know the argument has to be greater than 0, which is just the square root expression. So I will say square root of 2x minus 3 must be greater than 0. I can square both sides. If I square both sides, wouldn't I get x minus 3 is greater than 0 squared, which is just 0. So that is that. Add 3 to both sides. 2x is greater than 3. Divide by 2. I get x has to be bigger than 3 over 2, which means the domain is all these big numbers starting from 3/2, but no upper bound. It can be anything bigger than that. So 3 over 2 to positive infinity. So as long as you know to remember to set the argument greater than 0 for these domain of logarithmic functions, you will be okay. Just, I guess, one thing to be careful about is that you have to flip the inequality symbol because you divide it by a negative number. But if you can pay attention to those things, this shouldn't be too difficult. I'll tell you what's difficult though. The other two problems on part C and D. I will start another video for those because they're going to take much longer time. But that is it for A and B.